Hello, Andy Kettle here once again from Server Components and Systems, and here I'm going to show you how you can make a ARM Copley drive backward compatible with the previous one. A number of features were added to the drives, one being CAN improvements, and part of that range of improvements was a safety update, in that if there were any errors in the drive, then you would have to take your own action to reset it, i.e. the CAN interface would software disable the drive, and it would be for you to decide how you enabled it again. Now, many situations that would be okay, you could reset the drive automatically and using hardware enables, etc, etc. But if you've got a large network, then it might be prudent to have a second layer of safety which looks at all the surrounding states to see whether it's safe to move the motor or not. So don't forget, safety is not all about protecting the human being, it's also protecting your machine. So your overall controller will have more information available to it about the surrounding area than the server controller itself. So in their wisdom, they added this feature which disabled the software via the CAN. But you might not want that, and so they have introduced a bit which you can find in the parameter dictionary that we've got in front of us here. And if we look at parameter 0x121 and search down here, we can find references to it, and you can see that it was updated for the new CAN, well, not new CAN protocol, but the protocol for vehicle CAN communications, J1939, which was supported for the ARM and FPGA Plus drives. So if we carry on going down, we can see quite a few references to this, and finally, if we get to the instruction, the ASCII instruction, which is the OX121, and then come down a bit further and look at bit 1. Bit 1, we see if set causes the drive to go to CANOpen fault state when a fault occurs. Clear this for backwards compatibility. Now, word of warning here, this actual statement is incorrect. It's back to front. So new drives will be shipped with this bit 0. And in fact, all these bits in this word are set to 0 as default. And if you want to go backward compatible, you need to set the bit to 1. So right now, I'll go and show you how you can do that using the ASCII command line editor within CME2. So first of all, what we've got here is an AP2 module, and I've had it plugged into a development board. If you've got the serial comms mapped into your own PCB, then that's fine, use that. But if not, you can always purchase one of these development boards to program your module before you put it into your own application. So to set the bits, first of all, we must load up CME2. I've got version 8.1 here, which I would recommend use the latest version all the time. And here you can see I've got a drive come up. It's unnamed. It's a brand new drive straight out of the box. It's not been used yet. If I click on that, it will go and connect with it. There we go. And you'll see here all the commands you've got. And we're going to go to Tools, ASCII command line. So just to be sure that no bits are actually set, and I suspect they aren't, because I believe they are 0 by default, I'm going to get the value from that register. So to do that, we go into the command line, G for get register space 0x121 return, and there you can see we've got a value of 0. Now, so that's good, that makes it easy, because what I want to do now is set it so that bit 1 is set. Bit 1 in binary is actually a value of 2. So it's 1, 2, 4, 8, etc, etc. So what I do is now change this to set register OX121 space 2. It's got OK, so that's OK. Now just approve it. We can go back and get it again. Get RX 121, and it's set to 2. Now that's in RAM. The R means RAM. So I'm now going to change it so that it says flash, and that will mean it will be in there. Ah, sorry, I've got it from flash. You can see that flash is still 0. So if I set flash as well to 2, okay, that's it. That's all we need to do. So that bit is now set, and from now on it's now backward compatible with the older drives, such as the ACK, for example, which used the older 807 DSP processor. So that's it. Hopefully you'll find that useful. Thank you for watching. Bye-bye.